Welcome you students. In this video lecture, I will give a knowledge of laws of mechanics. Laws of mechanics or else principle of mechanics. Okay. So some of the laws we are having, the first one is a Newton's law. Newton's law. And the second one is principle of transmissibility. Principles of transmissibility. And the third one is Lami's theorem. Lami's theorem. Fourth one is Parallelogram Law. And the fifth one is triangular law. Sixth one is Polygon Law. And the last one is Newton's law of gravity. Right. Let's see one by one. First, start with Newton's law. So we have three Newton's law: Newton's first law, Newton's second law, Newton's third law. What do you mean by Newton's first law? Newton's law says that if a body in a state of rest or else in motion, then it continues to be in the same state unless or until an external force influences it. What it says? See, for example, just imagine ball is kept on the table. It is just in a rest position. Just it is being kept on the table. So unless or otherwise I disturb this ball, it remains in the same position. If I give some kind of push or pull to the ball, there may be a behavior just like a motion. But if I didn't disturb the ball, it just remains in the same position. That's what saying in the Newton's law. One more thing. Just assume there is a football which is on the ground. Okay. Now I just going to give the push. Okay, push to the ball just by kicking it. So what happens? It goes on moving with uniform motion. Uniform motion. If I didn't give any disturbance, that means in the path of the motion, if there is no barriers, it continues with the same order, motion. But if there is any kind of barriers, just like resistance force, then it comes to rest. That's what saying. If any object is in the state of rest or in uniform motion, it will be continuing its state until or unless any external force act upon it. Okay, fine. So what do you mean by the Newton's second law? Newton's second law. What it says? Newton's second law says rate of change of momentum is directly proportional to the force acting on the body and takes place in the same direction What it means? So rate of change of momentum. What do you mean by momentum? Momentum in the sense motion of a mass of a body. Motion of a mass of a body. Momentum, in the sense, motion of the mass of the body. I can say in the mathematical representation, P is equal to mass into velocity, product of mass and velocity. Okay. See, in order to understand the momentum, just imagine there is a bus which is traveling on the road just like this. Parallelly, on the side of the road, there is a car. There is a car which also rolling. Okay. Consider this is moving with the same velocity. Velocity of the bus and the car is a constant. Okay. Just imagine the drivers of the car and the bus trying to apply the brake at the same time. They need to apply the brake at the same time. Just tell me which one will stop at first, whether a bus or a car. Which one stop? Definitely a car. Am I right? This is because of momentum. That means when the mass increase, the bus experience high momentum. So when compared to car, the bus needs more number of force to stop it. So this is because of momentum. Okay. See, so here comes rate of change of momentum is directly proportional to force acting on body. That means F force is directly proportional to the formula. I can write F is equal to mass into velocity. Rate of change of momentum, am I right? For rate of change of momentum is directly proportional to the force. That means since it is a rate of change, for the particular time they are going to calculate. So divided by time we can add it. So here what comes? F is equal to mass into acceleration, because the acceleration in the sense velocity divided by time. So this is the formula for Newton's second law. It says when the force increases, automatically your acceleration will be high. When you are kicking the ball, based upon the force, your acceleration will be increasing. At the same time, we can say when the mass increase, the force required to push any of the object will be high. So all the variables here in this format will be directly proportional to each other, right? So let's move to the third Newton's law. Third Newton's law. Newton's third law. It's a very general one. Everyone knows it. That means Newton's third law says for every action there is an equal and opposite reaction. The best example I can say, if you throw the ball on a wall, what happens? It just returns back. Am I right? So at the same time, the person walking on the road, see, your foot is just pushing the ground backwards, and what happening? The reaction of the ground, which is what? Pushing the foot forward. So that's why we are moving. And the example I can say rockets. The action of the rocket is just pulling downwards, but the reaction making the rocket to go up, right? So this is the this is what about the Newton's first law, second law, and third law. Let's move to the second one, principle of transmissibility. Principle of transmissibility. See, in order to understand it, first I will draw a diagram, okay, so that you will get a better understanding. So there is a point A, B, and at the point A there is a force. I am making the force. Here as well, the same copy of this first one. So see, this force line of action, it is going like this. This is the line of action of the force. Line of action. This principle of transmissibility says the point of application of force, can be taken anywhere on the line of action, without changing the external force acting on the body. It also gives the same effort just it does in the previous one. So that I can say the force acting on A, we can also replace anywhere on the B or somewhere on the line of action. I'm going to take A. So it also causes the same efforts. For example, there is a bus, okay, which I going to give the push. Its line of action is going something like this. Okay. I also having the another bus. And this bus, I just going to pull it. Here I have given the push, and here I going to pull it. If the force is constant, here I take 10 Newton, here in the pull, if I take the force 10 Newton, if it is same, and if the forces are in the line of action, then the work or behavior or reaction happen in the first one will be similar to the second one. The effort will be the same. If you take the line or the point of application in the same line of action of the force. Okay. So this is what mentioning in the principle of transmissibility. Then move to the third laws of mechanics, which is Lami's theorem. Just I will draw the diagram first. So there are three forces. I'm going to take this as P, Q and R, and with respect to each forces there is an inclination, theta angle. I'm going to consider this as alpha, this as beta, this as gamma. Let's know about the statement. If any coplanar concurrent force acting on a point, that means coplanar in the sense the forces acting on the same plane, such kind of forces are acting here, coplanar concurrent force, all the forces are meeting at a point. Such force act on a particular point, then each force will be directly proportional to sine of angle between other two forces. What it exactly say? If you are going to solve force P, then I can say P is directly proportional to sine of angle between other two forces. What is the other two forces? Q and R, which in angle is alpha. So sine of angle between other two forces. And this Lami's theorem is worked out on the equilibrium condition. Okay, in equilibrium condition. So equal, I am putting equal, and if I going to take another force Q, it can be solved by the formula, that means Q is directly proportional to sine of angle between other two forces. That means in between P and Q there is an inclination which is beta, so sine beta. Similarly, or divided by sine opposite angle, that means gamma. So it says when a three coplanar concurrent force acting on a point be in equilibrium, then each force will be directly proportional to sine of angle between other two forces. Okay. So from that we have taken the formula. Then the fourth one, parallelogram law. Parallelogram law. Fourth one is a parallelogram law. Here comes, I'm just going to trace out the parallelogram. Okay, fine. So when a two force acting on a point, this is a point, from that I'm going to consider a two forces which are represented in a magnitude P and Q, and it has a definite direction, okay, and it is taken, these two forces are taken in the adjacent sides of the parallelogram, If any force act in such a way, then it resultant will act in the diagonal of the parallelogram, something like this. This is what saying the parallelogram. The inclination angle between P and Q, distance angle between two forces can be noted as theta. An angle between resultant and the horizontal component, we can take it as alpha. Okay. So by the way, what do you mean by resultant? Now we know when two forces act on a particular point, be represented in the magnitude and direction, then the resultant will be directed in the diagonal of the parallelogram. Am I right? So what do you mean by resultant? Resultant in the sense, number of force acting on a body can be replaced by a single force. That means, for example, there is a block, I have number of forces. It is acting such a way. Each one 10 Newton or 40 Newton, then 10 Newton. Okay. I can also replace by a single force, but it should cause the same effort that produced by this one. That means if I take the resultant force, I can say the resultant force will be, or how much, if you add it, we get 60 Newton. Here I have given the push with 10 Newton, 40 Newton and 10 Newton. It also produces the same effort. It also moves with some kind of the motion, particular distance. As well, if I push it with the force 60 Newton, that also produces the same effort. So such kind of things we can call it as a resultant. It is a single force. So that is what happening here in the diagonal of the parallelogram. And then the resultant formula, it is derived as root of p square plus q square plus 2pq cos theta. Theta in the sense, it's angle between two forces p and q. And as far as the direction, it's a resultant. Direction concerns, it's a angle of resultant. That alpha can be calculated by the formula tan inverse of q sin theta divided by p plus q cos theta. Okay. So this is for resultant and this is for alpha. Then let's move to the next one, triangular law. Triangular law. So its statement, when two forces acting on a point is represented in magnitude and direction, taken in order by the side of the adjacent side of the triangle, then the resultant force will act on the closing side in opposite direction. Okay, that means in a point there is a two forces P and Q which can be replaced as per the triangular law. See here, two forces which are acting something like this. Okay, so its line of action when you come to P, it is going something like this. Okay, so I going to just take the P force before the point in the line of action, and I am going to take Q force here, because triangular law says when two forces acting on a point is represented in magnitude and direction, then it is taken in the side of triangle in order, it is going in order, the same path. Then the resultant force will be in the closing side of triangle, which is noted in opposite direction. Both the forces are in order, but the resultant force which is acting opposite direction. This is what saying in the triangular law. So if I consider this as theta, the angle between two forces as theta, then the angle between two forces here in diagram comes here. Okay, then if I want to take this measurement, that means this angle, what would be the angle? I can say the full angle of this particular thing is 180, so that I can note 180 degree minus theta. Okay, and just like the parallelogram law, here as well we are having the resultant, which is P square plus Q square, and minus that plus, but here it is minus 2PQ cos 180 minus theta. 180 minus theta in the sense it's a angle between two forces. So just then there is a direction, am I right? So in the case of the triangular law, the direction of the resultants happens at this particular place. This is alpha. This can be denoted as alpha. Let's move to the sixth one, Polygon Law. Its statement also just similar like the previous one. Polygon Law. That means when a set of force acting on a point or acting on a particle, okay, is represented as magnitude and direction, which is taken in order, and the resultant force will be in the closing side of the polygon, which is taken in opposite order. That means polygon, we know the surface which has more than 3 sides, that is known as what? Polygon. So here the forces arrangements are something like this, F1, F2 and F3, which is something like this. Okay, all the forces are taken in order with specific magnitude and specific direction. Okay, then its resultant force will be acting on the closing side in opposite order. Here it is moving something like this, force 1, 2, 3, but the resultant force it just moving opposite in order. Okay, this is what the Polygon law says. And the last one is Newton's law of gravity. Newton's law of gravity. Seventh one. So this law states that the force of attraction between two objects or two bodies, the force is directly proportional to mass of two bodies and also its force is just inversely proportional to the square of distance between them. Okay, so for example, I can show the diagram. This is how the object, okay, this with the mass 1, this is a with mass m1, okay, and here one more thing, this is with the mass 2. So there is a force of attraction between the bodies, and each bodies are maintaining with a distance or as per this law, I can give the mathematical representation just like this. Force is directly proportional to m1 into m2, product of mass of each bodies, divided by the force is inversely proportional to distance between two bodies. That means inversely proportional to square of distance between the bodies, square of distance between the bodies. This is what saying in the law. If you just simplify it, instead of proportional, we can give the constant term which is g, so that it comes m1 into m2 divided by r square. Thus g is a universal constant or constant of Newton's law of gravity. Okay, it's a universal constant. This universal constant g has a value, standard value, which is 66.75 into 10 to the power 12 meter cube divided by kg second square. Okay, g is equal to, it's a constant term, it will be equal to 66.75 into 10 to the power minus 12 meter cube per kg second square. Okay, so for this Newton's law of gravity, I can give the best example as a earth and moon. What is happening there? If I consider this as earth and the orbit, the moon is just moving. There is a force of attraction between earth and moon. Am I right? It's maintaining the distance, is also moving each other, but it is not what? Coming closer. There is attraction, but it is maintaining the what? Definite distance between two bodies, right? So I can take earth and moon as a perfect example for Newton's law of gravity. So I hope you understood the laws involved in the mechanics. So in the coming videos, I'll be solving a problem based on the laws of mechanics. Thank you so much.